All right, let's get right into it. Welcome to this explainer, everyone. Today, we're going to completely optimize your daily coding workflows, and we're doing it by mastering one single, incredibly powerful concept, AI context within the Gemini CLI. Let's be real. If you've ever felt like your AI coding assistant is just kind of blindly guessing at what you actually want, you are absolutely going to love this. We're going to break down exactly how to ground the AI, seamlessly integrate it right into your editor, and leverage some seriously advanced features to dramatically speed up your whole development process. So here is our roadmap for today. We'll start with number 1, the why. Then 2, workflow integration. 3, multimodality. And we'll wrap up with number 4, expert management, for those really massive coding sessions. Kicking things off with section 1, the why, and what we're calling the AI vegetable game. Now, before we start hacking our daily routines, we really need to understand what problem context actually solves. Basically, context is the surrounding information you provide to an AI model alongside your actual prompt. Think about it. If you just tell the Gemini CLI to make the paragraph text bigger, it has absolutely no idea which paragraph you're talking about. Sure, it can scan your codebase and try to reason it out, but essentially, it's just making an ungrounded guess. By explicitly providing context, we completely eliminate that guesswork. Picture this. Imagine you're suddenly dropped into a room where people are just shouting out random vegetables one after the other. Broccoli, asparagus. Without any context, you wouldn't have a clue what was going on. But if someone pulled you aside beforehand and said, hey, they're playing a game where they take turns naming green-colored vegetables, well, suddenly you can jump right in and play along. This is exactly how AI models work. Giving the model your specific files or code snippets as context is literally like explaining the rules of that vegetable game before it even walks into the room. Moving right along to section 2, workflow integration. Let's look at this seamless, implicit workflow. Let's talk about the evolution of efficiency here. For a while, we had the manual method. You'd explicitly add files or folders as context by typing the @ symbol in the chat, followed by the file name. Gemini does this really handy fuzzy search of your code base, and you just pick the file you need. Great. But look at the implicit context method. If you install the Gemini CLI companion extension for VS Code, you literally don't have to type anything. Just by having a file open in your editor, the CLI automatically knows that the open tab is your context. It's incredibly seamless and just feels like magic. But sometimes even an entire file is way too broad. We've all been there, right? You're staring at some horribly stubborn TypeScript error, something super specific like type string or undefined is not assignable to type string. So how do we surgically fix this without making the AI read and reason through hundreds of lines of totally unrelated code? Here is the pinpoint solution, and it's a total game changer. Step 1, you just highlight the broken code directly in your editor. Step 2, keep it selected. Because you have that companion extension running in the background, whatever text you currently have highlighted acts as highly targeted implicit context. Then step 3, you simply jump down to the Gemini panel and type, there's a type error here. That's it. The model knows exactly which lines you mean, the guesswork is gone, and it fixes the bug instantly. It's an unbelievably powerful workflow for surgical bug squashing. All right, section 3, multimodality. We are taking things from visuals straight to code. Our source material points out something huge. Gemini models lean heavily into multimodality. This means they understand text, images, and other media as part of the exact same conversation. So we're pushing way beyond just text-based context here. We can actually use images as direct design references for our code. Let's put this multimodal magic into action. Let's say you're building a tags input field, and you want each tag to look like a little UI pill. You can literally take an image file, let's just call it pill.png, drop it in your project root, and reference it in your prompt using that same @ symbol. You just tell the CLI, please style the pill to look like the pill from the following image. But what makes this an absolute superpower for developers is combining that visual context with hard logic. In the exact same prompt, you can add, whenever a user adds a comma, create the pill, add a cross icon to delete it, no duplicate tags allowed, and max it out at 5 tags. The model actually ingests the visual design from the PNG and pairs it flawlessly with your programmatic constraints to generate a fully working, styled front-end component. Just amazing. Finally, section 4, expert management. Let's talk about managing the context window. As your day goes on, you're talking to the model, feeding it files, feeding it images, all of that info lives in the context window. And Gemini has a window of 1 million tokens. That is a staggering number. Theoretically, you could be chatting to the model all day long,
working across multiple different features in the exact same chat session, and you still might not hit the limit. It is massive.
But, and there's always a but, there is a hidden trap here. Just because you have a million tokens doesn't mean you should fill them all up. If you do manage to fill it, older context begins to slip out, and the model starts losing its grounding. But honestly, even worse than that is the danger of noise. Over a long coding session, your context window just fills up with irrelevant history, old debugging trails, maybe features you completely rolled back. All that extra noise dilutes the important logic, and that is exactly what causes confusion and makes the AI's output way less predictable. So, how do we keep our session healthy? Here's a rapid, highly actionable tutorial directly from our source. Step 1, just run the settings command right in your CLI. Step 2, tab down to switch over to your workspace settings. Step 3, key down until you find the setting called Hide Context Window Percentage and flip that value to false. Now, once you escape out of settings, you're going to see your remaining context space displayed as a percentage right in the footer of your CLI. It gives you vital visibility so you know exactly when your session is getting bogged down. When that window inevitably fills up, you have two strategic power moves. On the left, we have the / compress command. This is incredibly clever. It scans your entire session history and condenses all of that context into a compact summary of what's happened so far. It frees up a massive amount of space while preserving the core logic of your ongoing work. On the right is your nuclear option, the / clear command. This wipes the entire context window totally clean for a fresh start, without saving any summary at all. The rule of thumb, if you're starting a totally unrelated feature, use clear. If you just need some breathing room on your current feature, use compress. So, the absolute biggest takeaway here is that AI doesn't have to be this unpredictable black box. By using implicit file contexts, highly targeted code selections, and managing your token window like a pro, you are in total control. With the guesswork completely removed from the equation, how will you master context to reshape your own daily coding efficiency? I highly encourage you to go install that VS Code companion extension today and actually put these integrations into practice. Thanks so much for joining me on this explainer, and happy coding.